What is hydrostatic law? Hydrostatic law gives the pressure variation in a fluid when it is at a rest condition, and it states that the rate of increase of pressure in a vertically downward direction must be equal to the specific weight of a fluid at that point. Consider this is a container which is filled with a fluid. Now, this fluid is at a rest condition. Now, consider a small element of a fluid. One small element of a fluid. For our convenience, I make a rectangle. The small element of a fluid is showing as a rectangle. Suppose area of the small element of a fluid is del A, and height of this small element of a fluid is del H. The pressure is applied on face AB and CD, and let us consider the distance of this fluid element from the free surface of water is H. Now, there are various force acting on this fluid element. First, the pressure force which is acting on the side AB. Then force is equal to pressure into area. So pressure is denoted by P and the area of this fluid is del A. So the pressure force which is perpendicular applied on face AB is P into del A. Second, and opposite force is applied on the face CD. So P plus differentiation of change in pressure with respect to change in distance H into del H bracket into del A. So now third one is the weight of a fluid of this element. So what is the formula of weight? Weight is equal to mass into gravity. Now see here, what is the density? Density is mass upon volume. So mass is equal to density into volume into G. Now what is a volume? Volume is a area into height. So what is the area of this fluid element is del A and height is del H. So weight of this fluid element is density into G into del A into del H. Now on this side AC and BC and AD, the pressure forces on this surface are equal and opposite, so they cancel each other. Now for equilibrium of fluid, we resolve all the forces which is acting on this fluid element. Now the force which is acting on face AB is P into del A. Now now second force which is acting on CD is in opposite direction, so we take minus sign, and here P plus change in pressure upon with respect to change in distance H into del H bracket del A, plus again the weight of a fluid is acting in downward direction, so the direction of pressure on face AB is and the pressure which is and the weight of the fluid element is same. So the weight of a fluid, so we are taking plus sign. So the weight of the fluid element is density into G into del A into del H. Now resolve this equation. P into del A minus P into del A, it is cancelled because plus minus, its remaining is minus change in pressure upon change in height into del H into del A plus rho G del A into del Z. If we resolve this equation, then del A is cancelled by del A, Del H is cancelled by del H. So remaining part is change in pressure with respect to distance is equal to rho g. What is the rho g? Rho g is a specific weight of a fluid. So what hydrostatic law is saying? When you are going in downward direction, then change in pressure with respect to height is equal to the specific weight of a fluid at that point. And what we have done, we are considering a small element of a fluid, and if we taking for whole fluid, then we integrate the above equation. Change in pressure is equal to rho g del H. So P is equal to rho g H. So change in pressure, if rho g is constant, then P is directly proportional to H. So change in pressure is directly proportional to height. So it is proved that when we are going in a vertically downward direction, the intensity of pressure is increases.